Hello, this is my Math 118 extra credit presentation, and today I'm going to be presenting about a topic that I think is pretty related to this class and I wish was covered in this class. And so I'm going to be talking about sorting algorithms, specifically bubble sort. So if, for example, you have an array in Python, it would look something like this. You would have like numbers in here. Mm, Okay, and then if you called something like array dot sort in Python, um, it would sort this array, and then if you called array again, it would return something like -1, 0, 1, 3, 4, 5, 7, 9. So it sorts like this top array um, in ascending order. But then if you're actually thinking, okay, what does Python do in order to get this list sorted? Like, what is the algorithm behind this? Because it's sort of like behind the scenes. So there's a lot of different methods of doing this, which are usually covered in like a data structures and algorithms course. So for example, you could use something called merge sort or insertion sort, and then also quick sort. So like these are all examples of like sorting algorithms. Um, and there's a bunch more, but these are like the main ones that would be covered um, like in a data structures and algorithms class and also bubble sort too. And then so what Python is doing here is called like the algorithm that Python uses to sort is called Tim sort, which was developed by Tim Peters, and it's a hybrid between merge and insertion sort. And I think this topic is really interesting because it's a good way to learn about big O notation and algorithmic complexity, which is something that we learned about in class. So as an example, I'm going to be going over the theory of bubble sort and then also how to implement it in Python, and then also the algorithmic complexity of bubble sort. So the way that bubble sort works, we're going to use this initial array that I had as an example. So what bubble sort does is it sort of loops through the array and it compares numbers that are side by side with each other. Um, and then it'll end up bubbling the biggest numbers to the right. Um, and so the biggest numbers will move all the way to the right, and then using a for loop, you continue that until all of the numbers are sorted. So as an example, let's go over like the first iteration of bubble sort. So first you would compare these first two numbers, 1 and 4. And so those are in the correct positions because 1 is less than 4. And then the next two numbers are also in the correct position. And then the next two numbers, you would need to switch them because 3 is less than 5. So it would be like something like this. 5, 7, 9, -1, 0. And so this is what I was talking about where the biggest numbers get bubbled to the right. So like 5 is going to start moving to the right. Um, and then so you keep going and you compare 5 and 7 and that's okay. You compare 7 and 9 and that's okay. And then you compare 9 and -1 and you need to switch those two. So it would be 1, 4, 3, 5, 7, -1, 9, 0. Okay, and then keep going. Um, and then compare 9 and 0 and then switch those. So 1, 4, 3, 5, 7, -1, 0, 9. And so that's the first iteration done because we've reached the end of the array. And so like 9 no longer has anything to compare it with. So then you would start over and then you would loop through like this portion. And then at the end of the second iteration, at the end, it would look something like um, you would have like a certain amount of numbers here, and then you would have 7 and 9. And then you'd continue iterating through the array until you have the sorted array, and so it would look something like this. And so now that we have kind of a basic idea of how this sorting algorithm works, we're going to go into Python and see how it looks when you actually code it up. Okay, first I'm going to use that same array and we're going to test out Python's like built-in sorting algorithm. So the array that I used was -1, 0, 1, 3, 4, 5, 7, and 9. Okay, and then if we call something like array.sort, and then we return that array, you can see like now it's sorted. So we're going to try to build this from scratch using the bubble algorithm. So I already have the code written down and we're going to go through it line by line. So this is sort of what it would look like. I have this function called bubble. And then you have a nested for loop because this first for loop, you're looping through like every single element of the array. And then in the second for loop, that's where you're going to be like comparing the numbers that are next to each other. And so the reason why you're looping through from 0 to length of the array minus I minus 1, this -1 is because like once you get to the last element in the array, you have nothing else over here to compare it to. So you want to stop 1 before the end of the array. So for example, if we're stopping at 7, then we have something at the end to compare it to. So that's why this -1 is here. And then for this -I, when you're looping through the array and you have it oh, sorry. I just realized that that's the sorted version of the array. So let me type it out as like the non-sorted version. 1, 4, 5, 3, 7, 9, -1, 0. Okay. And yeah, we get the same thing because it's the same array, just sorted. Okay, so I was explaining this -I. So when you have the array and you're like bubbling up the highest number to the end, so for example, this 9 would go at the end of the array in this last position. So you don't want to keep comparing the numbers at the end, which you already know are like in the correct position. So like once this 9, for example, is moved to the last position, you don't have to check that it's sorted anymore. So you can just check this array, which is like 1 less than the full array. So the length of the array that you're checking is dependent on I. And so that's these two for loops. And then in here, this is your comparison logic. So you compare the two numbers. If the second number is less than the first number, then you swap them. So that's what this is saying. So like if you have this element and it's greater than the next element, you want to swap them. And then if not, you just keep them the same and continue with the loop. And then so this right here is the logic for how you would swap them. So like in Python, you would need to create a temporary variable and then assign the first element that you're swapping to this temporary variable, and then set that element to the next element, and then set the second element equal to the temporary variable. And that would end up swapping the two numbers into like the correct ascending order. And so let's try this out again with the initial array. So you have array, and then we're going to do bubble array, and then print out this array. Oops, sorry. Let me run this. Okay, and you can see that the resulting array is like the exact same as the built-in Python sorting. And then if you want to see like exactly what is happening at each step, we could do like print x. And so here we can see like how many steps it takes to sort through the entire array. And so like these three right here is what we were doing on paper, where it would be like the first iteration where the number 9 like bubbles all the way up to the top. And then like right here is when the next highest number bubbles up. So like 7 would bubble up, and then you continue that until the entire array is sorted. And then so if we're thinking about this in terms of algorithmic complexity, The worst case scenario would be um, the numbers are in descending order. And so you have like the two for loops. Um, and then for most double for loops like this, the algorithmic complexity would be O of n squared because you're going through like each element in the array. And then for each element, um, you would look through like the entire array again. So for example, like the length, we can check the length of this array would be 8. And then for each number in here, you're going to compare it again. So like it would be 8, 8, 8, 8, 8. And so that would end up being like n times n, like the length of the array times the length of the array, which is n squared. And so that's why like the algorithmic complexity of this would be n squared, which is not very great, which is why like the Python sorting uses a combination of sorting algorithms. I'm pretty sure it's because um, it's to get that like time complexity down because like obviously like for Python, the optimal sorting algorithm that you would want to implement is like the one that takes the least time complexity. So yeah, that was my presentation on bubble sort. I really enjoy like algorithms and data structures, and I feel like um, a lot of topics from computer science is good for data scientists to know just because it's just a good background to have. And then a lot of the topics like carry over, like for example, like algorithmic complexity. So when you're thinking about like modeling and doing that kind of stuff in data theory, you would want your model to be like as efficient as possible, especially when you're working with really large data sets. If your algorithm isn't very efficient, then it could take like a really long time for your model to run. So yeah, that was my presentation. Thank you for watching.